Happy Friday morning.
Happy Friday.
Happy Friday. All right, let's just jump right in. So, welcome to the Allison Loves Math podcast. I am super excited to introduce today's guest, Steve Warner. He's a math professor at Hofstra University. He's the founder of Get 800 Test Prep. He has more than 20 years of experience coaching students in math and standardized tests. And the coolest part of all is that he's an author of more than 30 books in math and test prep, including, which I'm super excited to talk about today, his Pure Math for Beginners series. So welcome, Steve. I'm super excited to have you on the podcast.
It's great to be here.
So, you have such, honestly, I'm so impressed at how many, as someone who's only written 2 books, but it was a big venture. I'm always interested to meet other authors and figure out, how they got to do all the things that they're doing. Can you just start by telling us a little bit about your background?
Sure. I'll just give a quick synopsis. I started tutoring math way back when I was in high school. And all through high school and college and graduate school, I was always tutoring pretty much full time. And I got my PhD in 2001, I believe. And at that time, I became a math professor. And at the same time, I started working for a local group in Staten Island, New York, which is where I grew up, doing SAT, ACT prep classes. And, a few years after that, I wound up getting so much clientele that I kind of branched off on my own and started doing my, running my own things myself. And then starting in 2011, I think it was, I wrote my first SAT math book. And then I just kind of kept writing books. So I wrote SAT books as ACT, GRE, the subject tests, AP calculus, prep books. And, and luckily they were all doing pretty well. So it allowed me the opportunity to attempt to write something that I've always really wanted to write, which just a few years ago, I wrote my first pure math book called Pure Mathematics for Beginners. And luckily, it turned out that people actually wanted this book, which was somewhat surprising to me. And it allowed me the opportunity to write a whole series. So I actually have a series of 7 pure math books now at this point, in addition to my 20-something or so test prep books. Yeah, so that's kind of where I am today.
Which I love. I love the idea of pure math for beginners, because beginners and pure math just are 2 words that don't always go together. But I love the idea of introducing it early. I know we were talking a little bit earlier about, the fact that when I was majoring in math in college, I was taking calculus and I never knew what was beyond calculus. And we were kind of commenting on the fact that there's so many students who actually, you don't really know what is beyond calculus. And I was halfway through college when I realized, I took my first number theory class and was like, oh, this is really different from all the stuff that we learned in high school, just sort of getting thrown into the deep end of the pool, So I love the series, and I love just this idea of, being able to introduce pure math to students earlier before they get to it, in their second or third year in college. So I think, based on the series and what we're talking about, I think I know your answer to the next question, but I'm going to ask it anyways, which is, what is your number one tip for parents whose kids, love math, they excel at math, to the point that they're not necessarily challenged in their high school math classes? What is the advice that you would give them?
Right. So there are definitely several different ways you could go with this, but my personal favorite, as you might have guessed, is to have your child learn some actual pure mathematics. Right. And there are other things you could do, but I enjoy pure mathematics, and it's a great way to increase someone's mathematical skill level. And it doesn't really matter what topic in pure math, as long as it's not too difficult. It could be set theory or abstract algebra, like you said, number theory, real analysis. So just kind of diving into these is, it's a much more challenging and rewarding way to build up your mathematical skill level. And it's not anything that's done in a typical high school curriculum.
Yes. And I think it's a really fun alternative especially for all of the families who have, advanced high school math students, and they just sort of throw them into more test prep. They just really go, we're going to do more SAT math. We're going to make sure you get that 800 on SAT math. But instead of just sort of obsessing over that one little area, which I understand it has a good payoff if you've got a really high SAT math score, but there are so many other areas of math that can be so interesting. And honestly, I think knowing and learning a little bit about that early on can have a huge payoff in college if students can figure out what it is that they love or what area of math they love, you know.
Sure.
All right. So and I guess because, you know, I did not know what pure math was in high school. I did not know what it was during my first year of college. Can you just, for parents who actually don't know, they're talking about pure math, but I don't know what that is. Can you explain what exactly is pure math?
Yeah, well, basically, pure math is mathematics that's done without worrying about how it could be applied to the real world. It doesn't mean it can't be applied to the real world. It just means it's pure math that's being done for the sake of developing math or learning math and doing math. That said, a lot of pure math either comes from one of two things. Either it comes from problems that are based in the real world, or it comes from generalizing things that are more applicable to the real world, right? So just to sort of try to give a little bit of mathematical example without getting too heavy into math. At the most basic level, you have arithmetic, right? Where like a typical arithmetic problem might be, if you walk 2 blocks and then you walk 3 more blocks, how many blocks did you walk? Well, 2 plus 3 is, I think, 5, right? So that's arithmetic. Then if you want to go one layer above that, you have algebra, which for those of you who don't know, algebra just means generalized arithmetic. So algebra is a generalization of arithmetic. So a typical algebra problem related to the last one might be, if I walk 2 blocks, and I want to walk a total of 5 blocks, how many more blocks should I walk? So 2 plus what is 5? And if you think about that, that should be 3, right? And then another layer on top of that, maybe you want to generalize further to abstract algebra. So what could you do in abstract algebra? Well, maybe instead of doing distance in straight lines, maybe you want to do addition along a clock. So for example, if it's 11 o'clock, what time will it be 2 hours later? And most people would say 1 o'clock. So when you do that, you're doing a little bit of abstract algebra. You're doing clock addition, right? And then maybe instead of a 12-hour clock, you use a 7-hour clock, right? Like what is 6 o'clock plus 2 on a 7-hour clock? And we actually use 7-hour clocks all the time, although some of you that don't know, it's just called days of the week, right? So if today is Friday, in 21 days, what day will it be? Well, since 21 is divisible by 7, it'll be Friday again. So before I get too mathy over here, which I think may have already happened, maybe we should move on.
Oh, it's good. I like the example with the clocks.
Yeah.
It's a really nice analogy.
Mm-hmm.
Okay, so I know we're talking in examples with clocks and stuff, but like you said, pure math is, you know, sort of removing the applications, right? Why is that something that would be beneficial for students to learn?
Well, so at its most basic level, learning pure mathematics is a great way to improve problem-solving skills, analytic reasoning skills, and more generally, if you study some pure mathematics and work on some hard math problems,
Actually,
you're
hang on.
going to be.
Oh, sorry, Steve, hang on 1 second.
Yeah, sure.
Sorry, your audio got really choppy.
Oh.
All right, can you move actually, let me just try again. Actually, say something.
Hello?
Hello? Okay, you're good now. All right, so,
Good.
sorry.
Okay.
Let me repeat that one question just because the audio got
Sure.
super choppy. Okay, sorry about that. Okay, what did I just ask you? I asked you why is pure math beneficial for students, right? Is that what I just, that is what I just.
That was the question, yeah. So, learning some pure mathematics is a great way to improve students' problem-solving skills, as well as analytic reasoning, critical thinking. And more generally, if you study some pure math and you struggle through some pure math exercises, you're going to see a pretty nice increase in your level of mathematical maturity. So for those people who don't know what mathematical maturity, which is maybe is everyone watching this, I don't know. It's not really a well-defined thing. Actually, if you ask 2 different mathematicians what it is, they'll give you 2 different answers, probably somewhat related, but a definition I like to use, especially at the high school level, is that mathematical maturity is one's ability to understand, analyze, and communicate mathematics. So someone with a low level of mathematical maturity can't do any of those things very well. And someone with a higher level of mathematical maturity might be able to solve new problems that they've never seen before by using techniques or modifying techniques that they've learned by solving other problems. And they'll be able to teach mathematics to others in a comprehensible way. So those are things you will pick up and get better and better at as you're learning some pure mathematics. Also, by learning some pure mathematics, we kind of talked about this when you brought up your number theory example. You were kind of thrown into the deep end of the pool in number theory, and you're probably like, what is this? We're not, there are no numbers, it's number theory, but where are all the numbers? And where are the computations? We're learning all this theory now. So pure math is very theoretical. And, I teach an introduction to higher mathematical reasoning course at my university. Hofstra University is where I work. And, students are often surprised when they get into that course that, number one, it's nothing like any of the computational math that they've done in high school or calculus or anything like that. And number two, they find it really, really difficult. So it's the first class that students who thought they were really, really good at math are realizing, wait, this is harder than I thought it was going to be. So wouldn't it be great if, more toward high school, you get exposed a little bit to some of this pure math, so you're not sort of thrown in like you are when you get, just kind of went into your number theory course and was like, just what is this? Yeah.
I remember, because I remember my advisor who taught pure math courses was just like, I'm teaching number theory this spring. It's going to be so much fun. You've got to take it. And I was like, all right, it sounds like fun. And then I was just like, what did I get myself into? And it ended up being a lot of fun. But the first couple of weeks, I was honestly, sort of like you said, I thought I was good at math. And I was like, I don't know what I'm doing. I never really felt so insecure about my math abilities. And there's definitely, I guess when you hit certain math classes or certain levels of math, all of a sudden there's this big jump in what you're expected to do. And I think you just talked about just the way that you talk about math and your ability to explain things, right? So all of a sudden you're trying to understand something that at the time seems so much harder, right? But in the sense, in a way, it might just be different, right? But because it's so different, it seems so much harder. But that really just, it forces you to sort of learn some new skills that you didn't necessarily have before. And yeah, I love the idea of having a little bit of experience with that earlier, because I think it would help students from being, like me, who didn't know, from being maybe a little bit blindsided by that first.
Yeah, well, certainly more advanced students who plan to go into a mathematical or related field like math or computer science or engineering or physics. If you're going into anything like that, I think being exposed to some pure mathematics while you're in high school, or at least between high school and college before you start college, is a great idea. And it's going to save you a lot of headaches when you are in college.
Yes, and it just gives you a little more time, I think, to think about, what type of mathematics you like, right? So we were talking about, there's pure math, there's applied math, there's statistics, and that was something also. And again, I think in this episode, I'm coming across as the most clueless math major ever, but in all honesty, I kind of was. I didn't know that there were different branches of math. I was, oh, you're a math major, and so it wasn't until I got beyond calculus and started thinking about what was beyond it, that I really realized that. And I sort of went down a bit of a pure math route because, we just had some fantastic pure math teachers. And so I was sort of drawn to pure math, I think more because the teachers were so excited about it. And then it really wasn't until, my junior year that I found statistics and realized, okay, this is my jam. This is the math that I love. That's what I want to do research on. That's what I studied in my master's. And, I do think that having that little glimpses of the different types of math before a little bit early on can just sort of help students to see, what is, you try different things and you find out what it is you really love,
Sure. Yeah.
All right. So let's see. You focused on pure math. So sorry, I was just talking about why I found that I love statistics. But you, on the other hand, pure math was your thing. Why did you decide on pure math as opposed to, applied math or stats?
Yeah, I think you hit on something when you talked about teachers, because, one of my favorite pure math classes was my course that I took in mathematical logic, and I just had a fantastic professor. Joel Hampkins was my professor for that. He's a very well-known mathematical logician nowadays. And also, when I was planning to go to graduate school, I met with Simon Thomas, who became my advisor, and he was fantastic. We would have these great discussions in his office, and I would learn so much just from spending a half hour in his office that I gravitated to that. So I would say it was a combination of having professors that I really liked that were teaching the pure math classes, together with the fact that I did really enjoy the subject matter, and I found it really challenging and rewarding. Getting solutions to some of these really difficult problems was really exciting and really rewarding.
It is super rewarding. I think that is the thing about it. You definitely have to love problem solving, right? And just really enjoy that feeling that you have when you finish solving something that at the beginning you didn't know if you had the ability to solve it.
It's a great feeling, yeah.
Yeah. So let's get a little bit more specific, because pure math covers a lot of different things, right? Lots of different entire courses that you can take in college. So for somebody who has a high school student and is thinking of introducing pure math to them, like specifically, like where would you start?
So in terms of topic, it doesn't really matter. It could be just some examples of things that would be acceptable to start with. You have logic, set theory, abstract algebra, number theory, real or complex analysis, topology, linear algebra. Those are kind of the 8 basic ones that I think of when I think of starting out in pure math. So any of those are great places to start. And those are exactly the topics I put into my pure mathematics for beginners, because those are ones where it's a great place to start. And they're kind of all a little bit interconnected too. You could find a little bit of each of those subjects within each other too. So the trickier thing, rather than worrying about what topic, is to get appropriate material, because when you pick up a standard textbook in pure mathematics, it could be very scary. Those books tend to be very dense. They don't explain everything. They leave a lot for you to fill in the details. And again, that's one of the reasons why I created my series of books. I wanted something out there that was a little bit more user-friendly, I think is probably the correct term for it. It hand feeds you a little bit more without expecting you to do all of the work. But at the same time, there are plenty of exercises so you get to practice, but then you can look at the solutions. A lot of these more advanced textbooks, the solutions are probably out there now with the internet and everything, but they're solved by other people, not by the authors themselves. So at least mine, you have solutions that are created by myself, rather than outside sources. Yeah.
It does sound a lot friendlier, more set up for self-study, right? Whereas, it's fine if textbooks don't have any solutions and stuff. You have the professor there, right? And the TAs to help sort of guide you through. But when you're trying to learn stuff on your own, it does help to have something that's more student-friendly.
Yeah, if you're diving into a textbook on your own for the very first time, it could be scary, and it could be a little frustrating, and you might be a little more likely to give up. So, just trying to find something that's a little more user-friendly, whether it's something from me or from someone else, that's definitely the best advice I could give, because I don't want you to give up. I want you to continue with math if you choose. If you really don't like it and it's not for you, that's great too, because now you've discovered something, and now you won't waste your time going down that path in college, and you could go a different way.
Yes, perfect. And yes, actually, I did have another question for you. So I know because you have the Pure Math for Beginners series, right?
Yeah.
And so but within that series, you have, number theory and abstract algebra, for beginners for each of them. But I know one of your books is actually Pure Math for Beginners, correct?
Yeah, that's right.
So is that one sort of like the starting place? Does it just sort of have a little?
Yes and no. I think it's a good starting place for someone who doesn't know anything about pure mathematics at all, because it's a great place to sort of just get a little taste of each topic, so you can see which one you actually like. Now, if you already happen to know that you like real analysis, then you could jump right into real analysis for beginners. None of the books have any topical prerequisites, so you could actually start with any one of them. But yeah, if you have no knowledge whatsoever about pure mathematics, then starting with pure mathematics for beginners, or rather at the high school level, I would actually recommend pure mathematics for pre-beginners, which is something that's even a little bit more transitionary into the more theoretical one.
Awesome. Cool. So pure mathematics for pre-beginners.
Yeah.
That sounds perfect. Gives them a little taste of lots of different topics, right? So they can see what's out there. And
it doesn't get bogged down in all the theory. Like pure mathematics for beginners is more close. It's closer to a traditional textbook, even though it's more user-friendly. So it's very, very rigorous. It's completely rigorous. Pure mathematics for pre-beginners is more informal. So it speaks as if two people are speaking rather than if a mathematician is speaking to a person, if that makes sense. Yeah.
Totally does. Yes, that's perfect. And so I think it's nice knowing that both of those books are out there, right? Because depending on your child, right, and where they're at and what they're interested in, you know, they might start with one versus the other. And I think they're both great starting places because, of course, I keep thinking about myself in high school and how I had no idea what any of the different topics were. So I wouldn't have jumped straight into number theory for beginners, but it's nice to have those books. As I was looking through, I was like, you've got examples from all of these different subjects. And I love having that little, you know, one example introductions to different topics. I really like that. All right, let's see. So sort of looping back to the SAT prep, right? Because I had mentioned before, you know, lots of parents spend a lot of time or have their kids spend a lot of time on SAT prep. But, you know, rather than say these pure math topics, but does this help? Can introducing your child to pure math early actually help students on the SAT or ACT?
Absolutely. And you know, a lot of parents, I think, want to get their children started really early with, you know, preparing for the SAT or ACT. In my opinion, you don't have to get that started that early. Like, yes, you should absolutely do test prep, but you don't have to do it start years before, right? But you can introduce the pure mathematics at any time. Now, what's great about learning some pure math, as I've already said, it increases your level of mathematical maturity. And what an increased level of mathematical maturity does for you in relation to test prep is it makes the process of test prep, number one, much easier, and it has a direct effect on your potential score. So what I mean by that is there are two things when you're ready to start your test prep. You have an actual score and you have a potential score. The actual score, let's take the SAT, for example. So suppose if you took the SAT right now, you'd get a 400 in math. That's your actual score. And suppose that a test prep professional or taking a course or preparing on your own, however you do it, can get you up to a 600. That's your potential score. Now, learning the pure mathematics will raise your potential score, not your actual score. So like as a simple example, suppose you have two students, they're identical in every way, and they both currently have 400 SAT math scores. One of them decides to learn some abstract algebra on their own for like 2 or 3 months, and then they both take an SAT prep course. They're both still starting at a 400, but the one who didn't do any abstract algebra, they're gonna get a 600, that's their potential. But the one who did some abstract algebra, they might get a 700 or an 800 because they've increased their mathematical potential by learning some more pure mathematics. And also, they're gonna have a much easier time. So they're gonna work much less to get a much higher score than the person who's working really, really hard to get just to the 600.
Yes, I think that's such a good point, right? That by introducing something that's harder and more challenging, you know, you learn something, you grow a little bit, and then when you come back to that SAT stuff, it's easier in retrospect, right? So it has that indirect ability to raise your score just by learning, you know, some math that's harder, which I think goes back to even calculus can be helpful, right? Just by
Sure.
some of that high school math that's harder, right? Can help because even though there's no calculus on the SAT, you've just spent more time figuring out and learning hard problems, right? And that's indirectly helps you even if calculus isn't on there.
Yeah, one thing that I think is a little hard for people to understand is how does learning math in a completely unrelated field help you with this math that has nothing to do with that? But surprisingly, it does a lot. Does a lot. Just as a really quick story, when I started graduate school, I had so much trouble my first year of graduate school to the point where I thought I was not going to continue. I struggled so hard to get B's for the first time, which might sound not that bad, but in graduate school, it's very bad. It's very, you know, they give away A's at graduate school. So if you're getting B's, you're not doing well. So that first year I struggled so much, and then I prepared for my qualifying exams, and I worked 8 to 10 hours a day on all this stuff. And then the second year, I was taking harder classes, completely unrelated to my classes from the first year, and they were very easy for me. So because I leveled up during that previous year, I was able to make the rest of my graduate school go much, much smoother.
Yes. It's really funny. I was almost thinking about back when I was doing SAT tutoring, which was a long time ago. And
Hmm.
as an SAT tutor, you'll probably shudder at this, but I had some sort of advanced SAT students, and we sort of just didn't have that many practice problems. There's more books. We've got all of your books for SAT prep that are out there now. But at the time, they're just I struggle to find some hard problems for students, and so
Yeah,
sometimes we would just go and I'd say, what, let's spend a week or two just doing some really hard math, and just when we jump into something that was just harder. And, sometimes that would help because we would come back and then all of a sudden the SAT stuff would just seem easier in comparison.
sure, sure. Yep. The only problem with that is that you need time.
It's
You
the
definitely need
time.
some time to work on the harder stuff. It's not something you want to do over a period of a week or two. It's something you want to do over a period of more like a few months to
Or like the
really.
summer. I think the summer was part of, what we would do is we just tackle these
Perfect.
harder math concepts. And you're right, it was partially for fun also, right? Because
Mhm.
it's not a time efficient way to study for the SAT for sure,
Right.
but it does help. And if you have a student who's interested in that sort of stuff, it can be a lot of fun as well as help on the SAT.
Yeah, and I do know what you're saying. In the past, when I first started doing test prep, it was very hard to find advanced problems because the tests themselves, if you wanted those level 5 problems, there were only one or two of those on any given test, right? So you only had a collection of 10 to 20 really hard problems, and then you had to either make them up yourself or you had to go outside of the SAT to find them. And a lot of the prep books back then, I wasn't crazy about them. So I would just really use College Board materials back when I first started.
Right. Right. And I think that's what happened to me actually, is I think I've got
Mhm.
somewhere on Google Drive, somewhere is just like loads and loads of random hard SAT questions that I wrote for students just because, you knew that they struggled with a certain type of question. If you couldn't find any, I just end up writing a whole bunch, which is a
Sure.
whole different thing. That really teaches you more about any sort of math if you're actually, once you figure out how to write the questions for it, that does definitely teaches you a bit about the subject as well too. It's sort of fun. All right. So let's see. I'm trying to think. I think we've covered most of our questions that I was thinking of asking you. Where can people find out more about you? So you have so many books, and I know you've got your test prep stuff as well. Where are the best places for people to get in touch with you and find out, get your books, all that sort of stuff?
Well, first, you go to my website, which is get800testprep.com. And from there, you could link over to a lot of my other stuff. You could go, if you want to learn more about me specifically, you could easily link right over to my LinkedIn profile. If you really want to see everything I've done, you could download my CV if you want to get that crazy. That's both on my LinkedIn and it's also on my about page of my website. You can also see all the books that I have available on my website. If you're like a teacher and you're planning on making bulk orders, you're best off contacting me directly because I can get you a discount from the Amazon price. Yeah, I also have a couple of Facebook groups. So I have a Facebook group for SAT prep and I have a Facebook group for pure mathematics. So feel free to join those groups if you're interested in that. And I have Facebook pages, I have Twitter, I have any type of social media that is out there. You can find me on there. It's not too hard.
Awesome. You're not too hidden.
Yeah, and you can always feel free to email me directly also at steve@satprepget800.com.
Perfect. Perfect. All right. And then to end on my favorite question, why do you love math? Or I guess more specifically, why do you love pure math?
Yeah, well, like I said earlier, I think it had a lot to do with the teachers. And funny thing is, when I started college, I started as a computer science major. And what I realized was, as I was taking my math classes, I really loved them. And as I was taking my computer classes, I found them really tedious. And at the time, I think we were doing C++, and I didn't feel like I was very good at it. I would make errors. I was careless, and it would take me hours and hours to decode things. And I was just like, but these math classes are so much fun, and like you don't have to decode anything. So I just really enjoyed the math classes. Specifically, I told you about a couple of teachers that really inspired me, that led me a little bit more in the pure math direction. And I think just naturally, I like solving problems for the sake of solving them rather than worrying about what they are used for. And so it's not that they're not used for anything, they certainly are, but let the applied mathematicians worry about that, and I'll just work on solving the problems.
That's great. That's great. Yes. And so teachers out there, remember that, because I think that's true for both of us, Steve, is that the teachers really inspired our love for math, right? So keep that in
Absolutely.
mind. Teachers, you are a huge influence on your students, and keep up the great work. So thank you so much, Steve. It was awesome to have you here today. I really, really appreciate having this chance to interview you today.
Yeah. Thank you for having me. It was great.
All right. And thank you for everyone who's listening. I'll see you next time. Bye.